myself. My name is Blake Robb. I'm the executive director of Bears on Patrol. It's a non-profit organization. We give teddy bears to police departments, and the police departments give these to kids in traumatic situations to help calm them, relax them. You probably met Camilla. She had a session earlier today. You may have been there. She is with NASA SDO, Solar Dynamics Observatory. And our project, it's kind of a unique partnership there, or cooperation. I started this idea a few months ago. I said, how many of you have seen any pictures or videos of people who've sent a weather balloon to near space, about 100,000 feet? Have you seen any of that? Yes, and you can see like the curve of the Earth and the atmosphere, the blackness of space. So, as a science in space kind of person anyway, I kind of thought, that's really interesting. I want to try that someday. And now as the executive director of Bears on Patrol, I thought, I want to see maybe if we can tie this into an awareness project. Let's launch a bear in a payload. So.
Now it's filed, but we want to keep this open to invite people to come in.
Okay.
No, it's okay.
So I decided to do that, and I had started following Camilla on Twitter.
You just have to project.
I decided, I've been following Camilla on Twitter for a while, and I thought, okay, well, space, this is kind of sort of related, let's see what happens. And I asked, hey, how would you feel about going for a ride in the balloon with us? And she went right along with it. And so this is what we're doing. And the sheet that I gave you has some of the basic details. It's kind of an awareness project for Bears on Patrol and science education. We want to show people that space exploration, a lot of people think about it, oh, that's NASA. They launch these multi-million-dollar shuttles and satellites, and that's who gets to space. We're stuck down here, and really want to show people with this mission that anybody really can explore space. You can get closer than you realize. We will be above about 99% of the Earth's atmosphere. We want to promote students to study science and get interested. Our capsule, this is a very basic diagram, obviously, of the layout of our capsule. This is going to be a weather balloon tied to the parachute and the payload. The payload is going to have GoPro video cameras, HD. One of them is going to shoot video, and one will be capturing photographs every 30 seconds. And if you go on the flip side of this sheet, you can see the equipment we have. We're going to use the GoPro cameras. You can actually see the inside of our capsule, the basic layout. We're going to be tracking with APRS. That's an amateur radio digital mode. It's automatic position reporting system or packet reporting system. And it will allow us, we can actually have a map up, and actually anyone online can look at our map and track the flight live. It'll have a little balloon icon and it'll be moving. So the way we'll be doing that is that little radio in the picture there. It's a 2-meter amateur radio, and it's connected to the APRS device that you see below it in the picture. And it transmits through the APRS device a digital signal in an APRS packet format. It'll tell the exact location of the payload and its altitude, and also the internal temperature of the capsule. That's going to be an interesting thing. There's obviously some obstacles for us to overcome there. The temperature in upper atmosphere is negative 90 degrees sometimes, depending on the time of year. So it will get very cold. Actually, this is kind of interesting. We have our payload the capsule is just basically a styrofoam cooler, and we are covering it with radiant barrier. It's an aluminum bubble foil It was actually developed by NASA, and it's still used. It was developed for spacesuits around the Apollo program, I think, and it's still used in a lot of their unmanned space
Have you
vehicles.
considered using Mylar?
Huh?
Have you considered using Mylar at all?
It may actually, is it maybe made of Mylar? I don't know.
I'm not quite sure.
But it is.
To look into.
It's a NASA-developed technology, and it can block up to 90%, 90 or more percent of radiant heat. So we'll have hand warmers, like the chemicals, and you break them and they get warm. We're going to have one of those in there just for good, to help it out a little bit more. And you see a picture of our tracking map. If you are Fuzz Aldrin's friend on Facebook or Twitter, he shares the links to this. You can actually go to this Google map and see a better picture. We are going to be launching from Houston, we're pretty sure. I run 2 trajectories. One of them is based in Carrollton, where we are, because originally that's where we were going to launch. Because of the cooperation with some of the members of our planning team, one is based in Houston, and he can get us free helium. That was a big one. So we think we're going to launch from Houston. So we have trajectory predictions for both locations. If anyone has any questions, go ahead.
Oh, yeah.
Yeah.
Like, is there going, I heard about the environment you're going to be in up there, but do you have any instruments that's sensing all this, or?
Yes, the APRS tracker will sense the internal temperature. I'm still looking and trying to find for a good cost thermometer. I'd like one, like you have at home. They have the indoor-outdoor thermometer that has the wire lead running outside, so you can see both, and it will record the record highs and lows. I would love to have one of those in there just to see the record highs and lows that we're getting inside and outside, see how well our insulation and heating works to keep the temperature down. What else? We're going to have radiation.
Yes, we're also adding a couple lightweight. The main issue right now is weight.
Yes.
Especially since we're going to fly those 2 mission mascots up there, so we can really capture, kids' attention. So weight is a little bit of a problem. So what we want to do is find items that we can fly that have some scientific value. And there is, for example, those badges you see when people work with radiation. They change colors. And so we want to see if we can put one of those on that's lightweight. We just had a discussion yesterday with some colleagues over at NASA Goddard about a film. They have a piece of film that they can also use to get radiation readings. So we want to see if that might be an option to put in there. The original intent has grown from there to now dramatically. I mean,
Yes.
we just wanted to send those 2 up and
Basic awareness.
basic awareness, and suddenly it has become so much more. We have a really interesting team that helps us with all of this, because neither of us has ever launched a balloon. So it's
Yes, as we said, it started, basic awareness. Let's raise awareness for Bears on Patrol and for, science education. And now it's really an educational opportunity, and I think we sort of changing the way we're doing things now that these opportunities came up. If you wanted to do this, and you go online and see, okay, what am I going to need to do? You kind of have to dig around and look at all these different sites, and a little bit you're on your own, coming up with, okay, what challenges am I going to face, and now how am I going to address those challenges? This is a really great opportunity for the science education aspect of our mission to put it all in one place. And if you're friends with Fuzz Aldrin, he has a Facebook account, a Twitter account. We are kind of openly sharing as the mission goes along what we're working with. One of the situations recently was we're launching from Houston, and our trajectory predictions have a lot of times been taking us into the Gulf of Mexico. Well, okay, now we have $200 or $300 worth of equipment on the payload. We're going to have to prepare for a water landing and keep everything safe. So we have to make the capsule waterproof, and making the capsule waterproof presents now a problem. When you're going way up in the atmosphere, the atmospheric pressure changes are very dramatic. I can't remember specific numbers, but they are very dramatic. So if it's watertight, it's airtight, and so we have the air in the capsule, basically it could explode if we didn't do anything for that. So, you know, that was an opportunity to write our mission blog about pressure changes. We have, we're putting check valves in the capsule so that it will equalize pressure as it ascends, and as it descends, it'll be doing the inverse. So we get to talk about near space conditions, atmospheric pressure. We're going to be above 99 or 98% of the atmosphere.
So, if I may ask, in insulating it, do you just consider the differential in terms of like sensitivity for any readings that you take? Once you insulate it, obviously you lose some capacity for some of the readings, correct?
Right, for the outside temperature?
Right.
Right, yeah, because it's going to be, hopefully we plan, it's going to be warmer in here than it's going to be out there at 100,000 feet.
So you just calculate that as just
So,
error?
like I said, what we want to do, our APS tracker has the temperature sensor. It'll be inside and it will capture that temperature. I would like to get an electronic thermometer with a wire lead that, you know, an indoor-outdoor thermometer, and it'll capture highs, record highs and lows, so I can see what we got on our flight. So if we get that to happen, we'll have a wire lead that will go out, so the insulation won't offset anything. I will get the actual outside temperature.
Kind of a historical note, I don't know if it's still going on right now, but I remember years ago that a lot of the people I used to work with came out of Rice, and they were in the space science department, and they'd go out to Palestine, Texas, to do their, weather balloons and high observations.
Yeah, it's only a balloon test facility.
Is it still running, or is it working with them, or?
Actually, it is. I was actually just there in May testing my camera system that I built for high altitude. It's actually part of my college.
Oh, great.
Part of
Yes. But it has, like you said, it's been incredible seeing the change in the way we're doing things and what we're planning to do. You know, it's like, we got all these people involved. You know, we started out and it was just, I pitched the idea and he got on board and it was basic awareness. Now we have, I'll tell you, we have a private Facebook group for our mission planning team, and some of connections of friends of ours got more people added. We have somebody with a PhD in plasma physics. We have aerospace engineers. So we definitely have experts working on it. Yeah.
And sorry if I interrupt.
Go ahead.
One of the main purposes when we did this was we wanted to put together a mission as real as possible to what it would look like if you did a space mission, like a space shuttle mission. And it started off, we created a patch, and we wanted to put as much thought into the patches as possible as we do at NASA. Each patch has a meaning behind it. So we created a patch with meaning. There was one of them.
Take a look at it.
So we created this patch.
Somebody asked for your URL, if that's what you want.
For,
I mean, you don't have to give anything you want, just
That's probably for him. So the mission patch we created has, of course, the BTS-1 logo on it.
Sean Schrader.
It has two constellations. One is Little Bear for Fuss, and one is the yet-to-be-discovered constellation Polis for chicken. And we have a blue ring around it, which represents Earth. And the red ring is, with the white, is representing the United States, the three colors of the flag. We have a night star, which represents Bears on Patrol, because that's when usually the teddy bears go to the kids, because nighttime is usually associated with, increasing crime. And the star on the other side is the sun, which represents Camilla. So we put all of this together with a real meaning. What we wanted to do is we wanted to really get kids involved at some point and see how a mission works, from initial design or concept to design, and then, of course, the development. And throughout the development, you learn things that you didn't even think of. And so the whole process we want to put together in a way that we can make like a manual for it.
Right.
So that future ideas, they have something to go back to. And here's how this has already evolved. While we're still working on BTS-1, there is one member in the group that has started to work with his school on BTS-2. And BTS-1, like Blake said, will be a capsule coming down on a parachute similarly to Apollo. BTS-2, the idea is to have a shuttle, an orbiter that comes back, remote control landing on a pre-designed area. And that's where we get more interest, if we can evolve in this and get schools involved and kids interested in being part of it and helping with the design and the challenges that arise from it. It definitely has gotten much bigger than we anticipated. And if any of you have input and ideas and suggestions, please do help us.
Okay, I'll give you my contact information.
Awesome. Because
Great.
we've never done this before.
We haven't, and it's been amazing, and it's exciting to see, because, it just shows that there is importance to what we're doing. This isn't just a fun little project. It's to see the people who have come forward that wanted to help, because they had the experience, and they're just as excited about the science, aerospace engineers, and all kinds of scientists that want to make this successful and help educate people.
So have you ever launched one of them?
We tested at the test facility. We were actually supposed to launch in September, but our launch got delayed because of the mishap that happened in Australia. We were actually supposed to fly in September, so then we got delayed till May of this year. So we've already gone through a thrown back chamber 3 times and successfully tested.
Now that's probably a much bigger size than what we have, right?
Oh, what camera is this? That's the size of the camera. It's actually only about like that.
Wow. And where are you launching from?
We're going to be launching from Palestine, Columbia, the balloon test facility out there in Palestine.
Now, one team that is also helping us, unfortunately they have been a little busy down in the Antarctica with flying their balloon. I just forgot their name.
Well, that's probably the part of the crew that was going to help launch ours. Was this time of year they go down to Antarctica for their balloon.
Yeah, it's like a long duration balloon flight.
That's part of why we got delayed, because then we got the go-ahead a month later. And then they're like, oh, we're shipping everybody down there that's going to be, you need, it's like, oh, okay, great, thanks.
Okay, that's interesting. We really hope that we not only learn more about the workings of all of this, but that we can share the excitement and get more schools involved, because I think those are really great school projects, and if we can, encourage kids and teachers and educate them about how this works, I think that would be a fantastic little outreach tool.
It would. We already have, like you said, we would like in the future to be better with directing it more towards schools, but we already have, like I said, we share everything that we're currently doing, the problems we're facing, and we already get interaction on Facebook. It's exciting to see people ask questions about the specific problem, like the pressure problem in the valves, and they're already excited and asking questions, and you get to see people learn with us. Like we'll say, well, we already know what's going to happen to the balloon when it gets up there. Do you, the average person, know? We ask on Facebook, okay, what's your guess on what do you think is going to happen when this balloon gets up to 100,000 feet or that area? Tell me your guesses, and then we'll let you know. And people would give their guesses and say, then we tell them, okay, well, it's going to burst because atmospheric pressure is less, the balloon's going to get bigger, and it's finally going to burst. And then they say, well, why is this going to happen? And you get to explain it, and it's an educational process through the planning and development stage. And I think, we're going to have people tracking online and watching while it's happening.
And then, of course, the footage that we get from it, we want to really make something nice out of it. And we're constantly adding little items to it. Like, for example, we got a previously flown item, previously flown in space item added on, and we want to put it into the capsule and say, okay, this item has already flown in space. We're going to bring it back to the edge of space, just as like an interesting component to it. It's just, we want to also have a little bit fun with this. That's why Camilla and Fuss will be there, and Sky Blue will assist in this. So we really want to make this a fun little exercise.
Our weight limit is, we mentioned that was an issue. We didn't mention that it's 4 pounds. That's actually for FAA regulations. If you have to stay under 4 pounds. If you get it over 4 pounds, there are more requirements to what you need. Radar reflector and 2 cut-down devices that operate independently. There was a lot of tricky things that get added on if you go over that weight limit, and I think it's going to be a lot of technical difficulty to make that happen if we got into that weight class. So, but at this point we were at like 3 pounds 2 ounces, I think, at our last measurement. So we're staying within our weight limit. And we have links on this page to. You can actually, there's sites for our trajectory predictions. There's sites to find us on Facebook and Twitter. Anything else we need to add?
Thoughts and ideas? What do you think about this concept?
I think it's exciting. That's my perspective on it. With my background in high altitude cameras, I'm excited to see stuff like this.
Mm-hmm.
What drew you into our little session here?
Well, I really just came in just to see what was going on, so I can't really say that I did it with a lot of fun.
Well, we'll see how this first mission goes. And,
I think that's part of the excitement of the first mission. A little bit that we don't know exactly what's going to happen. We're going to plan because we plan for these things. Okay, the temperature is going to be really cold. We're going to try to do this. The pressure is going to do this. We don't really know, and is it really going to go exactly real close to where it's projected to go that day? And are those valves going to be good enough for the pressure? Is it going to stay warm enough? And I think that's a bit of the excitement.
Where are you launching from?
University of Houston.
Okay. Central campus.
Huh?
Central campus.
Yeah, I think so. Yeah.
And we've come to the realization that we can fail. It's okay if we fail.
Right. Sure.
There's potential in this, and if it fails, that's even more reason to go back to the drawing board and go over this again and figure out what happened. Because again, we want to make it as close to a real mission as possible. And how many times have we had setbacks at NASA, some bigger, others not as big,
Exactly.
but we have always learned something out of it.
Right. We'll have after the mission, if we have a failure, and we'll go back and we'll have like the mission debriefing, and we can blog about it and share. Okay, well, we know the valve was rated for too high of a pressure and it exploded, or whatever happened. We can tell you exactly this is what went wrong, and this is how we can fix it next time.
So, Brandon, let me ask you a question. Would you be interested in going to a launch of a balloon that goes up to the edge of space?
Yes.
Yes? See, would you want to build one yourself? Maybe a rocket? Because
That's the problem I was having. We were trying to get students interested, and they were always interested in the rockets, but they were not interested in the balloon aspect.
Yeah.
Right.
They're like, oh, okay, a balloon.
Yeah.
And I'm like...
And I think the pictures and the video help there.
Yeah.
Really, that's just, I mean, those stories they're still making the news. Have you seen, there's articles and even on TV sometimes that they've made the news that, they've gone to the edge of space and you can see the curve of the Earth and the blackness of space, and, the news, they're still excited about that, and there's been, at least probably a dozen that have done this already. So, and I think we talked about this in our planning group. Part of this is to educate people. And I think a lot of times when you read the news stories, the news, they don't get it exactly right. This balloon went into orbit. Well, no, it didn't go into orbit. It didn't make it into space, and, you have to try to educate people. This is exactly where it's going. It's not quite up there, but it's, at this level.
You'll have to forgive my ignorance, because I'm complete layman in regard to everything going on here at SpaceUp, or SpaceUp, but as far as, I can see the challenge in terms of presenting it as a, something to embrace, the public to embrace, when you've got, fireworks going on in terms of space exploration, yada, yada. But I would think that probably the best way, in addition to engaging people with education, obviously the footage is amazing when you see the Earth from the high altitudes. But one thing that strikes me is that what you never see is the balloon itself at that high altitude. So what you might consider, and like I said, I'm a layman, I don't know what I'm talking about, but the first thing that I would think that would probably illustrate or illuminate the magnificence of it is the perspective of the balloon onto the Earth. So let's say you have, and this is hypothetical, I don't know what goes into the science of it, but you have, I don't know, two connected balloons. Obviously, having a camera that shoots the balloon, unless you have a very tiny one, I don't see you getting high quality footage. But, two connected balloons, whatever. But one that actually has a camera focused on the other balloon with, say, a fisheye lens, so you can get the horizon as well as the balloon. And if you make that kind of the focal point of propaganda in terms of, this is our icon, this is our little guy exploring, the edge. It seems to me that would probably provide kind of, like I said, the icon by which you could really put a face on the project.
Right.
It's a very good point. One thing that I talked to Blake about was I would like to have a third camera. And the third camera at this point would be here looking up, looking at the balloon. And you will probably only see the balloon for the first, I don't know how many minutes, but then the moment it bursts, you will get some amazing footage. And then once the balloon is gone, you would see blackness.
Yeah.
And hopefully, if everything goes well, you would see the thing tumble for a little bit and the parachutes opening up. And then you would see the parachutes. And so we have a team, MaxQ, really awesome guys. They do a lot of stuff down at Kennedy Space Center during launches. They're going to take our footage and they're going to put it together. They're going to make really nice multimedia out of it. So if we can edit different perspectives, different views, I think that will be exactly what...
The different perspectives would look fantastic. I mean, in regard to the point I was making, though, do you understand the distinction between the perspective of the balloon in the picture with the horizon?
Right, he's talking about having the camera here.
Yeah, right. So
you're talking about having
the balloon, but all you've got, is you've got negative space behind it, so you don't really have the familiarity of our home, our...
Right. You would have one up here pointing down, and the curve of the Earth down here.
Right, or, as much of the balloon as you can get in the picture in addition to the horizon.
Yeah.
And like I said, the only way I can imagine to do that would, as absurd as it sounds, to have, another, conjoined twin, so to speak, to carry the weight, And would you, if you did something like that, would you run into the problems with, you said there was a weight limit for the FCC. If you had two conjoined balloons, would that still... Would you still run into the same problem with the weight limit?
I would probably assume so, because that probably comes across as one unit.
Yeah.
If they're tethered, they're probably going to be considered one unit.
Yeah. But I exactly know what you're saying. There was a British balloon that they did, and it was actually really cool. They had like a little arm out here.
Right.
And they had 2 teddy bears on there sitting. And so they had a camera here, and they captured the teddy bear sitting, and you see the curve.
They were like spacewalking.
It was brilliant. I loved it.
Yeah.
I mean, that was awesome. Maybe there is an option that we can add something here and have a camera out here. We kind of have to do a little bit of research, but I really like your idea, and I would love to put a third camera on that mission, just exactly to see what happens to the balloon and how the parachutes open up.
Like I said, more importantly, I think,
That image.
as far as getting recognition and
Right.
kind of, getting motivation and interest in the project in general, if you make the balloon as much a character in your story, then that's when you're going to get a groundswell of interest, in my view.
That's an interesting idea. Yeah, I like that.
Have you considered approaching Cub Scouts as a group to work with? Or something like that? Because I think, if you get into, I'm not sure what degree you're looking for kids to be involved, but Cub Scouts seem like to me that they'd be a perfect group to do that, because they've got all sorts of badges.
Right, there might be
That they're trying
something
to,
that would fit.
Yes, and also for the recovery,
Yeah,
for the recovery process.
there's all sorts of things that they're always trying to get credit for, and there's, craftsmen would be building something useful out of different materials, and so if they construct a balloon, that would be certainly part of that, and then there's different types of science awards that they would be involved with.
And what we also want to do is at the launch day, we want to have a little event before the launch, and have, I'm going to be talking to JSC next week, getting some support from them, maybe have an astronaut or 2 at the launch, and so the kids come too, and can watch this go on. So yeah, we still have a lot of things to plan, but we're always looking for input and suggestion and ideas, so we want to make this a little fun and different.
And another advantage of Cub Scouts is that there are a lot of organizations in the NASA area, and so many of the parents are involved in the space program that are astronauts. And so that, it's another way of getting that support.
Exactly. Awesome, yeah, so we're looking forward to it. It will probably be early May. We're currently scheduling for early May launch. So we still have some time, but we want to get this balloon up, and we're going to have some fun with it.
Yeah.
So if there are no other questions, thank you so much for listening in. Go enjoy some other talks if we still have some time for the next session.
Can you guys both give your names once again?
Sure. My name is Blake Robb.
Romeo Dersher.